Very good evening, all. Very good evening. Can you hear me? All of you, can you hear me? Good evening. Good evening. Can you hear me? Am I audible? Pushpendra. Okay. Chalo, chalo. Come on, come on. Anand Prakash. Good evening. Good evening. Come on, come on. Keep calculator ready. Ramanjanelu. Good evening. Good evening. Ajay Kumar. Okay. Pranshu. Good evening. Dr. Uma. Good evening. Chalo, chalo. Keep your calculator ready. Okay. Now we'll take up one question. Before I go to the question, let us brush up some of the fundamentals. Okay, right. Take this question. Right. A mixture by mass of 80% nitrogen and 20% carbon dioxide enters a nozzle of a turbojet engine. Okay, let this be the nozzle. Please note down that nozzle need not be Akshay. Good evening. Let's do it. Very good. I have shown you the shape of the nozzle. Don't think that nozzle is always converging. No, it can be converging, it can be diverging. If the nozzle is converging, it means the Mach number is less than 1. If the nozzle is diverging, it means Mach number is greater than 1. Okay, Nishan, very happy to see you. Okay, let this be section 1 and let this be section 2. The fluid is entering and the fluid is leaving. Okay, here we have nitrogen, mixture of nitrogen plus carbon dioxide. I repeat, nitrogen plus carbon dioxide. Have a look at this. Raj Rishi. Oh, great. बहुत दिन के बाद मिल रहा है. Let us do this. Mixture of nitrogen and carbon dioxide is entering and leaving this nozzle. The inlet pressure is given as how much, sir? The inlet pressure is 600 kilopascal and the inlet temperature is 1000 Kelvin. And the exit pressure is given as 80 kilopascal. But I don't know what is the exit temperature. Please note down that it is not a single gas. It is a mixture of gas. It is a mixture of gas. So I can treat carbon dioxide as an ideal gas. I can treat nitrogen as an ideal gas. The mixture can be treated as an ideal gas. Sir, dew point of air cooling lower than entrance. Outlet क्या बोला है? केमिकल डिपार्टमेंट सर ड्यू पॉइंट ऑफ एयर फॉर कूलिंग टावर. अरे यार प्लीज यहाँ पे कूलिंग टावर का काम नहीं चल रहा है. सुनो. अरे यार आप भी प्लीज आस्क रेलेवेंट थिंग्स. आई विल कम टू यू. डोंट वरी. बताऊंगा. सी बिकॉज आई टॉट एवरीथिंग इन आरएसी. चलो रिलेवेंट क्वेश्चंस पूछो. जो चल रहा है उसी का पूछो. आई एम कमिंग. ओके सुनो रे. एनीवे लास्ट में आई विल टेक अप योर क्वेश्चन. डोंट वरी. Look at it. Now observe here. The air is entering and the air is leaving. Okay, no problem at all. Now, please note down that the Cp value of nitrogen and carbon dioxide is given CpCv and CpCv for oxygen is also given. एक second सुनो. I have given you one equation. The equivalent specific heat is given by M1 Cp1 plus M2 Cp2 by M1 plus M2. This is for the mixture. Do you remember? This is for the mixture. M1 CP1 plus M2 CP2. Let me try to calculate equivalent specific heat for equivalent specific heated constant pressure of the mixture. Okay. Let us take nitrogen as 1 and let us take carbon dioxide as 2. अरे नाइट्रोजन को 1 मान लेंगे, कार्बन डाइऑक्साइड को 2 मान लेंगे. So CPE can be written as M1 by M1 plus M2 into CP1 plus M2 by M1 plus M2 into CP2. Okay. Look at my dear students carefully. Can we write this as mass fraction of nitrogen? Already given 80% nitrogen. What does 80% mean? Out of the total mass of 1 and 2, nitrogen mass is given as 80%. That is, this is 0.8. And this is the mass fraction of carbon dioxide. And that is given as 0.2. So Cp equivalent is equal to 0.8 Cp1. What is Cp1? It is the specific heat of nitrogen, because Cp of nitrogen is 1042. Wonderful. Plus M2 by M1 plus M2, that is given as 20%. This is 20%, that is 0.2. And Cp2. What is Cp2? 842 divide bus. यही तो है. This is 0.8 into CP1. This is 0.2 into CP2. CP2, this is for carbon dioxide. CP1, it is for, but see the unit. See the unit, my dear students. See the unit. The unit is joule per kg Kelvin. Sorry, it is joule per kg Kelvin. So therefore, you will get equivalent specific heat. Can anyone give me the value of CPE? Can anyone give me the value of CPE? मैं आपसे विश्वास करना, आपको बिलीव करना मेरा मूर्खता है. It really कितना आ रहा है सर? 1002 unit joule per kg per Kelvin. On similar grounds, let me calculate CVE. On similar grounds, let me calculate CVE. CVE can be written as M1 CV1 plus M2 CV2 by M1 plus M2. So therefore, the equivalent specific heat is given by, separate karo, M1 by M1 plus M2. Okay, M1 by M1 plus M2 CV1 plus M2 by M1 plus M2. It's a request to all of you. Please make sensible comments. Please only related to subject. Okay, M2 by M1 plus M2 CV2. Anyway, I'll not see all those things. Okay, the equivalent specific heat is given by, what is M1 by M1 plus M2? It is 80% CV1. What is the specific heat of nitrogen? Dekho, nitrogen CV is 745 plus M2 by M2 plus M2 is 0.2. It is 20%. CV2, dekhna ek bar, all of you. CV2, it is 653. It is 653. Can you give me the value of CVE? Anyone? Nishant. Only Nishant has given 0.2 into 653. Kitna aa raha hai sir? 726. Wonderful. 726.6 unit joule per kg per Kelvin. Now, can I calculate equivalent gamma? It is CPE by CVE. So the equivalent gamma is given by CPE. What is CPE? 1002. What is CVE? 726.6. So therefore, now let me calculate equivalent gamma. Kitna aa raha hai sir equivalent gamma? 1.379. So I will take this as 1.379 is equivalent gamma. Ab dekhna. Now we have converted complete mixture into a single mixture. Now observe here. Dekho ek baar. All of you listen. All of you listen. What is he saying? Reversible adiabatic. Already mixture is ideal gas. You know, PV power gamma is equal to constant. In order to apply PV power gamma is equal to constant, what are the conditions? 3 conditions must be satisfied. What are those? The working fluid should be ideal gas. Yes, this mixture can be treated as ideal gas. It is reversible, already given. They go expands reversible and adiabatic. So now I can apply, all of you listen. Now I can apply T2 by T1 is equal to P2 by P1 power gamma by gamma minus 1. But here gamma should be for mixture. I repeat, this gamma should be for mixture. This gamma should be for mixture. Already you have calculated. Kitna aaya, sir? How much is that value? 1.379. 1.379. All of you listen. So the final temperature by T1. What is T1? All temperatures should be in Kelvin. 1000 is equal to P2 is 80 and P1 is 600. Power gamma is 1.379. Oh, sorry. This should be gamma minus 1 by. Okay. Yes, Rohit. Okay. It is gamma minus 1 by gamma. I'm sorry. Is it correct? Yes. Gamma minus 1 by gamma. 1.379. Correct now? Is it correct? Yes, 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 yes. 80 by 600 to the power 0.379 divided by 1.379. So I think I'm getting this value as anyone. Wonderful, Ajay Kumar. Ajay is the right, has given the right answer. 574.7. 574.7 Kelvin. Is it clear? Clear? If it is clear, then I'll move ahead. The question is not over. The question is not over. Find the exit temperature and exit velocity. Okay, now he is asking exit velocity. Dekho ek baar. He is asking exit velocity. Nozzle can be treated as a steady flow device. So let me apply steady flow energy equation between 1 and 2. What do I get? Let us apply steady flow energy equation. Observe here. Applying steady flow energy equation. किसके लिए apply कर रहे हैं? I'm applying for the mixture. Now you forget nitrogen, you forget carbon dioxide. It is a mixture. So now applying steady flow energy equation for the mixture which is flowing through nozzle. What will be the equation? What will be the equation, my dear friends? Wonderful. Dekho ek baar. H1 plus C1 square by 2000 plus Z1G by 1000 plus Q is equal to H2 plus H2 plus C2 square by 2000 plus Z2G plus W. Can anyone in the class tell what is the value of W? What is Ajay? Wonderful Ajay. Wonderful Ajay. Wonderful Ajay. So nozzle, neither you are giving work nor you are getting work. I repeat, for nozzle, neither you are giving work nor you are getting work. For nozzle, neither you are giving work nor you are getting work. And already you know it is adiabatic. So Q is 0. He has not talked about potential energies. So this is also, sorry. Oh my God, how can I remove this? So potential energies are not given. We can neglect. तो ये गया. तो अब देखो, already he used one word. It enters with negligible velocity. He clearly said, means this velocity is negligible. Entering with negligible velocity, C1 is negligible. So H1 is equal to H2 plus C2 square by 2000. This equation you have applied for what? You have applied this for what? Anyone? I have applied this for mixture. So H1 is Cp of mixture T1. H2 is Cp of mixture T2 plus C2 square by 2000. Please note down. ये किसके लिए apply किए? We have applied for mixture. So therefore, now Cp equivalent into T1 minus T2 is equal to C2 square by 2000. So C2 is equal to under root of 2000 CPE. C2 is 2000 CPE into T1 minus T2. Okay. So C2 is equal to under root of 2000. What is the equivalent specific heat, my dear students? Anyone? What is the CPE? CPE. I forgot. What is CPE? CPE is 1002. But it should be in, dekho, you all should be in kilojoule per kg Kelvin. So Cp should be in kilojoule per kg. I repeat, my dear students, why did you divide with this with 1000? Actually, it is C2 square by 2. We have divided this with 1000. The reason is to keep all in kilojoule per kg. So when you keep all in kilojoule per kg, when you divide with 1000, this becomes kilojoule per kg Kelvin. Okay, kilojoule per kg, I'm sorry. Now, this should be in kilojoule per kg Kelvin. So therefore, it is 1.002. Hope you understood. Hope you understood. That's why attending basic classes is very, very important. Into T1 minus T2. What is T1 given? T1 is given as 1000, and T2 is 574.7. C2 is equal to anyone? Anyone with C2? I am getting this as 923.2. Is it correct? I am getting this as 923.2. Is this correct? Wonderful, my dear students. 934.9. I am getting 923. Hope the question is clear. Hope the question is clear. Clear? Now we'll go to a different question. Yeah. This is a good question again. Take this question. Take this question. Zero point. Shall I proceed? Zoom करना है इसको. अरे यार, can't you see? अब दिख रहा है? Now can you see? Can you see? Clear है? Visible है ना? Okay. Is it visible? Take this question. Again a good question. Again a good question. 0.5 kg of air. Initially at, what is the pressure? 90 kilopascal. What is the temperature? देखो एक बार, 70 degree. You convert in Kelvin, 273 plus 70. So how much is this? 343 Kelvin. Okay. In a piston is compressed reversibly adiabatic. देखो एक बार. Please understand the question properly. It is compressed reversibly adiabatically to a pressure of, it is compressed to 0.4 megapascal. Please don't get confused. This is in kilopascal, this is in megapascal. So if you multiply this megapascal with 1000, समझ में आ रहा है ना? You'll get it in kilopascal. अब बताइए, what is this kilopascal? अरे 0.4 megapascal. Shall I write it as 400 kilopascal? You're not saying anything. Only Nishant is commenting. बाकी के सब ऐसे ही बैठे हैं. Okay ना? Okay? 400. Okay. Now, it is then expanded reversibly at a constant pressure to the final volume. Okay. 1 to 2 is reversible adiabatic compression. 2 to 3 is constant pressure. And then it is cooled to initial state. कहाँ है? Then it is cooled to initial state. कहाँ है? To initial state. Okay. Right. And it is expanded to the initial state. मैं explain करूँगा. Don't worry. अब पूछ क्या रहा है? Calculate. I'll tell you. Calculate the work, calculate the heat in each process and the cycle. Okay, network of the cycle. Also find the mean effective pressure, the mean effective pressure and the cycle efficiency. Assume that air behaves as an ideal gas. ये सब दिया है. Now let me do this question. Let me explain what the question is saying about. मैं बताता हूँ, सुनो. This is a good question. Now I'll tell you. Let us take let this be P, let this be B. What is 1 to 2 process? 1 to 2 क्या है? It is reversible adiabatic. It is compression. So you are compressing from the initial state 1 to a final state 2. This pressure is given as 400 kilopascal. And this pressure is given as कितना दिया initial pressure? 90 kilopascal. They are in kilopascal. Kappa. They are in kilopascal. Okay. Okay, fine. This is reversible adiabatic. Air can be treated as ideal gas. So can I write this as PV power gamma is equal to constant? Can I write it as PV power gamma is equal to constant? Yes, I can write. Let this volume be V1 and let this volume be V2. We have compressed from volume V1 to volume V2. Then what he said? Please read the question carefully. It is then expanded at a constant pressure to the initial volume. It is then expanded. देखो, it is then expanded at a constant pressure to initial volume. This is the initial volume. At a constant pressure, it is expanded. Wonderful. It is then expanded to a constant pressure. Wonderful, my dear students. Wonderful, my dear students. उसके बाद क्या बोला? It is cooled to close the cycle. Yes, it is cooled to close the cycle. These are the processes. So please tell me, is the cycle clear? Now let me represent the same cycle on TS diagram. Bolo sirs, is it clear? Is it clear? Now what is 1 to 2? Reversible adiabatic compression. Yes, it is. Reversible adiabatic is isentropic. Reversible adiabatic is isentropic. What is 2 to 3? It is constant pressure. It is constant pressure, heat addition. So this is constant pressure on TS diagram. This is a constant pressure heat addition. So let us say this is 2 to 3. And what is 3 to 1? 3 to 1, it is constant volume. Constant volume. Observe here. This is a constant volume process. Now please understand carefully. I have shown the slope of, understand carefully, I have shown the slope of 3 to 1 more than the slope of 2 to 3. Hope you have understood. So this is constant pressure ye wala, and this is constant volume. Hope you understood. Hope you understood the logic. So this is asked in to represent. Is the question clear now? Now what he says is there are so many things to be calculated. Yeah, this is a good question. So why I say it is a good question is there is a reason. The reason is only initial conditions are given and we need to calculate all. If one calculation goes wrong, everything will go wrong because it is all linked. That's why whenever you come across such questions, you should be very careful with calculation part, because because we are connecting from 1 to 2. If during the process of calculating from 1 to 2, if something goes wrong, khatam hai. Okay, na? Is it clear? Okay, chalo. Now, please observe here. I think some other data is also given. Mass is given, initial temperature. Now, can I calculate V1? It is a closed system, so mass to constant rahega. P1 V1 is equal to mRT1. Let us try to find out pressure, temperature, volume at all points. If that is known, the rest is simple calculation. I repeat, the first step is let us calculate pressure, temperature, volume at all points. Ab dekh raha, I want V1. What is V1? MR T1 by P1. Whenever R is in kilojoule per kg Kelvin, P should be in kilopascal. How much mass is given? 0.5. What is the value of R? 0.287 air ke liye. It is air. And what is the initial temperature given? 343 by P1. What is P1? 90. Why are you putting in kilopascal? Because this is in kilojoule per kg Kelvin, therefore this should be in kilopascal. Can you give me the value of P1? 0.5 into 0.287 into 343 divided by 90. So, कितना आ रहा है सर? 0.5469. गलत. Ajay, you are wrong. Acha, sorry, you are right. I'm sorry, Ajay. You are right. Okay, now, I know V1. How much is V1? 0.547 ले ले. Ajay said, चलो 69 ले लेंगे. Now, can I calculate V2? Anyone? Yes, I can calculate because P1 V1 gamma is equal to P2 V2 gamma. Correct now? P1. What is P1? 90. V1 0.5469 and gamma it is air is equal to P2 is 400 into V2 I do not know and gamma is 1.4. So आप बताइए the value of 90 by 400 exponent 1 divided by 1.4 into 0.5469. Anyone? Wonderful, Uma. V2 is equal to 0.1884. So therefore it is 0.1884. ये आ गया आपका. ये आ गया. V2 आ गया. So can I calculate T2, my dear students? Yes, I can calculate. Can you help me as to how to calculate T2? I'll tell you. T2 by T1 is equal to P2 by P1 gamma minus 1 by gamma. I can write this equation. What is the reason for writing this equation? Because 1 to 2 is reversible adiabatic. For reversible adiabatic, I can write this. There is no harm. So T2 by T1. What is T1? I think T1 is given as 343. P2 is 400 by P1 is 90 power 1.4 minus 1 by 1.4. So therefore 400 by 90 power 0.4 divided by 1.4 into 343. How much is this? 525. Wonderful. T2 is 525.2. So we have calculated the temperature here. यहाँ का temperature कितना है sir? 525.2. Yes. Temperature is known, volume is known, pressure is known. Temperature is known, volume is known, pressure is known. The only thing is now we are left with 3. Already at 3, the pressure is known. How the pressure is known? Because 2 to 3 is a constant pressure process, so it is 400. And already the volume is also known. Anyone? What is the volume at 1? What is the volume at 1? 0.5469. The volume at 1 is also known, so no problem at all. The only unknown at 0.3 is temperature. The only unknown at 0.3 is temperature. Now you tell me, how do I calculate temperature at 0.3? V3 is already known, na? How V3 is already V1, na? V3 is already V1. Are yaar, V3, V1 are same. So therefore, V3 is also equal to V1. That's what I said. Already V1 is known. So that's what I said. V1 is V3. I don't know T3. How do I calculate T3? How do I calculate T3? Anyone? What is 2 to 3 process? It is constant pressure. PV is equal to MRT. M is constant, R is constant, pressure is constant. Volume is directly proportional to temperature. So therefore, V3 by V2 is equal to T3 by T2. So therefore, V3. Can I write V3 and V1 as same? Can I write V3, V1 as same? 0.5469 by V2. What is V2? 0.1884 is equal to T3, I do not know, by T2. What is T2? 525.2 कितना आ रहा है सर? Divided by 0.1884. T3 1524.8. Wonderful. Where? Which 2 to 3 re baba? I'm writing Nishant sir, it's constant volume process, not constant pressure. I'm writing for 2 to 3 sir. I'm writing for 2 to 3. Any problem sir? I'm writing for 2 to 3. Any problem? एक बार बोलो. Any problem? बोलो. I'm not writing 3 to 1. कहाँ 3 to 1 लिखा? 3 to 1. Nishant, is it clear? Nishant, I wrote clearly 2 to 3 na? Clear na? No problem. Clear ho gaya na? Yes, wonderful, wonderful. So I have this temperature and that is 15. कितना आ रहा है सर? 15? 24.6. चलो 1525 ले लेंगे. Now I'm ready with all. Up, let us calculate heat and work for various processes. Before that, let us write all values carefully. P1, V1, T1, P2, V2, T2, P3, V3, T3. है ना? What is P1, sirs? What is P1? I think P1 is given 90. V1 0.5469. T1, 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 T1. Anyone with T1? 343. P2, 400. V2, V2 0.1884. And T2, 525.2. P3, P2 and T, same P3. V3 is V1, 0.5469. T3 is 1520. I forgot 1525. Now no one can stop me. You tell me what is 1 to 2 process. It is a reversible adiabatic. यहाँ लिखेंगे. So identify the process, apply the equation. No one can stop you. What is it clear? यहाँ तक is everything clear? यहाँ तक is everything clear? Okay. What is 1 to 2 process? It is reversible adiabatic. What is 2 to 3? It is constant pressure. What is 3 to 1? It is constant volume. No problem at all. You tell me what is the heat transfer in 1 to 2? Because he is asking us to calculate heat transfer and work transfer in various processes. Can anyone in the class tell what is the heat transfer in 1 to 2? I'll be very happy. What is the heat transfer in 1 to 2? No one is wonderful. 0. Why? It is adiabatic. It is adiabatic. How do I calculate work in 1 to 2? For reversible adiabatic, P1 V1 minus P2 V2 by gamma minus 1. Correct now? It is reversible adiabatic. No one can stop me. P1. What is P1? 90. V1 0.5469 minus P2 is 400. And V2, what is V2? 0.1884 by gamma is 1.4 minus 1. Please give me work in 1 to 2. Please give me work in 1 to 2. If you give, I'll be the happiest person. Anyone with work in 1 to 2? कोई नहीं दे रहे. Work in 1 to 2. Anyone work in 1 to 2? No one has given. Wonderful. Minus 65.3. Only Dr. Uma has given the right answer. Nahin? और कौन दिए? Ajay has given, Akshay has given, Rahul Ratan. It is not plus. Minus 65.3. Can you tell me the meaning of minus? Can you tell me the meaning of minus? अरे मीनिंग बोल रहा हूं रे. It is compression work. Work is done on the system. Okay, we have calculated heat in 1 to 2, work in 1 to 2. Now let us go for 2 to 3. It is a constant pressure process. Let us go for wonderful, wonderful Nishan, 2 to 3. Can you tell me what is the work in 2 to 3? Anyone in the class? What is the work in 2 to 3? Ab dhyan se suno. For constant pressure, it is P into, we are moving, see, constant pressure process is occurring from 2 to 3. So therefore, it will be, the pressure is either P2 or P3 into change in volume, that is V3 minus V2. Is this work positive or negative? It should be positive because it is expanding from 2 to 3, volume is increasing. So therefore, the work in 2 to 3, you can write either P2 or P3. You can write either P2 or P3 or P, all are same. So what is the pressure at 2? It is 400. And what is V3? 0.5469. And what is V2? 0.1884. Can you give me the work in 2 to 3? It will be positive work. Anyone with work in 2 to 3? Work in 2 to 3. Wow, J. Genius of India. Unit. The pressure is in kilopascal, therefore the work will be in kilojoule. Pressure is in kilopascal, therefore work is in kilojoule. Ab batao. Now you tell me, how do I calculate heat transfer? You know that d dash q is equal to du plus d dash w. Understand carefully. If you want heat transfer in 2 to 3, so I told you in my regular class, whether I write d dash q or q, it is same. Just to show that heat transfer and work transfers are path function, I write d dash. Du means what? Change in internal energy, U2 minus Un. And it is an ideal gas. For an ideal gas, what is the change in internal energy? Du is mcv dt. You are applying this for 2 to 3. For 2 to 3, this is final, this is initial. mcv dt. dt means change. Change is always final minus initial. That is T3 minus T2 plus work. What is that work? 143.4. Wonderful, my dear students. Heat transfer in 2 to 3. How much mass is given? I think mass is given. Somewhere mass is given. Somewhere mass is given. 0.5 kg. Mass is 0.5 kg. Yes. 0.5 kg. Mass is 0.5 kg. It is air. What is the working fluid? Air. For air, what is CV? 0.718. 1 second rukna. T3. What is T3? 1525 minus T2 525.2 plus 143.4. Can you give me the value of Q23? Anyone in the class? Q23. No one is giving. Are Q23 re? I am waiting for your answers. 502.2. Wonderful. Correct. 502.2. Wonderful. Wonderful. अच्छा 504 दे रहा है. चलो कोई नहीं. Around that. So we have calculated work in 2 to 3, heat in 2 to 3. Wonderful. Now let us go for, you tell me, now I'll ask you a simple question. What is the work in 3 to 1? What is the, देखो इसको ऐसा simplify करेंगे. Let us love the procedure. What is the work in 3 to 1? What is the work in 3 to 1? अरे यार ये कौन है रे इसको see if you attend my classes I explain very clearly. For constant volume it is mcv dt, for constant pressure it is mcp dt. So what is the work in 3 to 1? It is a constant pressure process, therefore it is 0. Wonderful. Can anyone help me as to how to find heat transfer in 3 to 1 in a simple manner? You know, for a cycle, sigma q is equal to sigma w. Q12 plus Q23 plus Q31 is equal to W12 plus W23 plus W31. Okay. What is Q12? What is Q12? 0. What is Q23? What is Q23? 502.2. What is Q31? I do not know. Work in 1 to 2. Already have calculated work in 1 to 2. Minus 65.3. Minus 65.3. Work in 2 to 3. What is work in 2 to 3? 143.4. Work in 3 to 1, 0. Can you give me the value of work heat in 3 1? Anyone? Yes, you can do that. Ariyar, d dash q is equal to du plus d dash w. For 3 to 1, work is 0. So heat transfer in 3 to 1 is internal energy change mcv dt. It is from 3 to 1. So T1 minus T3. Whether you are calculating from this or this, you will get the same answer. कितना आ रहा है सर? कितना आ रहा है सर? Yes, it is minus 424.4. So इससे कैलकुलेट करेंगे. Mass is 0.5. CV is 0.718. T1. What is T1? Anyone? What is T1? What is T1? 343. T3. What is T3? What is T3? 1525. कितना आ रहा है सर? -4. Yeah. -424.3. Is it not the same? See the beauty. See the beauty here. नहीं यार आपको समझ में नहीं आया समझ में. Same आ रहा है. Same आ रहा है. That is the beauty of the subject. Now he is asking network. Can I say network as work in 1 to 2 plus work in 2 to 3 plus work in 3 to 1? Yes. Network is equal to, what is the work in 1 to 2? 1 to 2 minus 65.3. What is the work in 2 to 3? 143. ये पागल है ये. What is the work in 2 to 3? 143.4. And what is the work in 3 to 1? 0. You tell me what is the network. What is the network? Anyone? No problem. JRD. Small error. It doesn't matter. Anyone? What is the network? Network 78 point. Is it correct? Someone cross check and give. Only Uma has given 78.1. Someone cross check. Wonderful. Network. Ab efficiency pucha hai. Can you tell me what is the efficiency? Efficiency is equal to net work by heat supply. What is the network? 78. Heat supply. You tell me. You have, dekho, what is the heat supply? There are three processes. What is the heat transfer in 1 to 2? 0. What is the heat transfer in 1 to 2? 0. It is adiabatic. What is the heat transfer in 2 to 3? We have supplied. What is the heat transfer in 2 to 3? 2 to 3 is a constant pressure heat supply. And you tell me, where are you supplying heat? We are supplying heat only in one process, that is 2 to 3. You are supplying only in one process, that is 2 to 3. You are not getting the point. I want heat supply. I want heat supply. So please listen carefully. Galat. So why are you giving 358 something? Why are you giving 358 Umaji? Huh? I said heat net work by heat supply. वही तो mistake कर रहा है. Net work by heat supply. Net work by heat supply. Heat supply कहाँ पे हो रहा है? सिर्फ 2 to 3. And what is the heat transfer in 3 to 1? It is not supply. It is, you are mistaken. You are mistaken. Let me show you the cycle. देखो एक बार. Reversible adiabatic, constant pressure like this. What is the heat? This is 1 to 2, 2 to 3. Okay. What is it supply or rejection? Anyone in the class? Is it supply or rejection? Is it supply or rejection? It is rejection. Is it supply or rejection? It is supply. Is it supply or rejection? 0, 0, 0, 0. Bolo, sir. Is it clear? Now you tell me where is the heat supply? Only in 2 to 3. So therefore efficiency is net work by heat supply, or network kitna hai? 78.1. Heat supply. It is occurring only in 2 to 3. Only in 2 to 3. Only in 2 to 3. How much is the heat transfer in 2 to 3? How much is the heat transfer in 2 to 3? 2 to 3 ka kitna hai? 502.5. कितना आ रहा है सर efficiency? कितना आ रहा है सर? Wonderful question. Wonderful sir. क्या मजा आ गया देखो. It is point. अरे आप लोगों को बिलीव नहीं करेंगे रे. Mains it is 15.54%. Wonderful. और क्या पूछ रहा है? You can also go by 1 minus heat rejection by heat supply. Where is heat rejection taking place? 3 to 1, 3 to 1. What is the heat rejection 3 to 1? 424.4. 424.4 by supply 502.5. कितना आ रहा है बोलो? कितना आ रहा है बोलो? 424.4 by 502.5 minus 1. कितना आ रहा है सर? 15.5. Is it not the same? Is it not the same? Again, it is same. Last one, very important, mean effective pressure. If you attend my classes, I will tell very clear. I had told you very clearly. So therefore, mean effective pressure is always equal to net work by swept volume. कभी भी याद रखना, swept volume means maximum volume minus minimum volume. I repeat, swept volume is always maximum. Where is the volume maximum? V1 is maximum. देखो, the piston, it is something like this. एक बार मैं बताता हूँ. It is something like this. The piston is sweeping between this, and this volume is swept volume. So maximum volume is V1 and the minimum volume is V2. The maximum volume is V1 and the minimum is V2. So therefore, the mean effective pressure is given by net work by V1 minus V2. So the mean effective pressure is given by net work. What is the net work? 78.1 unit kilojoule by swept. V1. How much is V1? Anyone? I think we have written somewhere V1. कहाँ गया रे? V1 is 0.5469. 5469. And V2 is minimum 0.1884. Let us check the unit. This is in meter cube. This is kilojoule means kilonewton meter. Kilojoule का मतलब न्यूटन मीटर by meter cube. So this is gone. Kilonewton per meter square is kilopascal. कितना आ रहा है सर? 0.5469 minus 0.1884. Into 78.1. So I think you are getting this mean effective pressure as 217.8 kilopascal. Let me check. Wonderful. Correct. What is the physical significance of this problem? You tell me, in this problem, what is this 217.8 showing? You tell me, what is this 217.8 showing? It is showing it is such a pressure, and if the fluid is expanding, at a constant pressure for that swept volume, for developing same work, this much pressure is required for maintaining the constant pressure. Hope you have enjoyed the questions. Hope you have enjoyed questions. मजा आ गया? मजा आ गया? See, my dear students, like we have this batch, accelerate batch for GATE and ESE. देखो, we have this accelerate batch for GATE and ESE. All top educators will be taking. मजा आ गया ना? मजा आ गया ना? This is accelerate batch for GATE and ESE. So it is starting from कहाँ? 4th August. It is starting from 4th August. If you want, you can enroll. And we are trying our level best to give you the beauty of the subject. All top educators are in a single frame. You can see all these top educators are in a single frame. ये भी है देखो यहाँ पे ये भी है देखो रे, इसको भी देखो थोड़ा. Okay, thank you my dear students. Love you all. चलो bye bye. Questions अच्छे लगे ना? Hope you enjoyed questions. मजा आएगा. Magic at top. अरे ऐसा नहीं. TD is enough. Okay ना? चलो. Thank you. Thank you. God bless you. और कल और अच्छे questions आएंगे. So in thermodynamics किस एरिया से मुझे चाहिए? अच्छा, इसको कूलिंग टावर का चाहिए. I will chemical department. I'll give you. Please, I cannot give you in a simple way because I have to start the groundwork. I cannot give you. So you can. This is my number. You can call. You can message me. I'll reply to you personally. Okay. Okay na? Chalo. Thank you, Anil. Thank you. Chalo. Bye bye. Okay na? चलो बाय बाय. थैंक यू. नहीं, अभी थर्मो कंप्लीट होने के बाद आई विल डू एफएम. सो थर्मो में किस एरिया से चाहिए आपको? किस एरिया से थर्मो चाहिए, किस एरिया से चाहिए थर्मो के, ये तो एक्सेलरेट करेंगे आपको, we'll accelerate because we have got some specialized team so that yes yes एक से बढ़कर एक, you'll take you to the, they'll take you to the final journey. चलो ठीक है, bye bye, thank you my dear students. चलो we'll meet again. Kulkarni sir signing off. Bye bye, God bless you, love you all. चलो thank you, I'm closing the session. Thank you, thank you. Bye.